Today I am going to talk about AdaBoost, which is a popular boosting algorithm. So the steps of this AdaBoost algorithm are as follows. First, it will actually AdaBoost is an ensemble algorithm because it combines or ensemble some weak learners. For example, you can take several decision trees and you can add to predict something. I will come to this, and then it will assign weights to the misclassified points, and then sequentially the tree will grow considering the past mistakes. So let us take an example. For example, suppose there is a dataset D1. So there are two types of classes, one is plus and another is minus. So at first iteration, if you take a decision tree with a height of 1 and you train the model, so what you will get is you will get this type of structure. So it will create a hyperplane to separate these two types of data points. So you can see that h1 is a hyperplane, and here these 3 points which are circled are misclassified. So what it will do is it will give some weightage to these misclassified points, which is alpha 1 here. And and in next iteration the dataset will be changed. Now this dataset will be D2. So here you can see that the plus signs, the size of the plus sign have increased. It means that it is given more weightage to these points, and which is called upsampling. So now in second iteration the dataset is D2, and now the next decision tree will
Sir,
run. Yes.
sir, in this, what is the significance of that alpha? What is that alpha doing?
Yes, actually alpha 1 means I'm coming to this. Alpha 1, it means because these points are misclassified, so it will give some weightage to that point, so that in next iteration it doesn't misclassify these points. Have you
Sir,
understood?
but sir, alpha is less than one, so is it dividing? I mean,
So you
I
can,
did not understand how that works.
okay, I'm coming to that. So I will show that. So so this alpha is calculating as 0.42, and it will give some weightage to this misclassified points, and now the dataset is D2. Now the second decision tree will run or train on this D2. So now the second hyperplane is H2. So now you can see that these minus 3 minus points are misclassified. So now this alpha 2 is 0.65, and how this alpha is calculating, and there is a mathematical deduction. I will not go into the details, but actually these alphas are calculating in such a way. uh, for example, this epsilon is weighted classification error. It means the how much the classification error for this model, and then depending on this epsilon it will give some alphas or some weight to this misclassified data points, and alpha is dependent on epsilon. So in second you can see that these 3 minus points are misclassified, so it will give some weightage, which is here 0.65, some weightage to these data points. And now in third iteration my data set will be D3. So you can see that these 3 points are larged, or it has given some weightage or upsampled these points, and now the data set is D3. And next, at last, it will take a next decision tree 3. So it will train the model on this data set. Now you can see that h3 is this hyperplane. So you can see that there is a misclassified point here and here, but in first one h1 and h2 is already taken care of this type of misclassified points. So you don't have to worry about that. So now you can see that what AdaBoost is doing, that it will merge three types of three outputs of the decision tree. For example, it is coming from the model 1, it is coming from model 2, and it is coming from model 3. So what it will do is it will give some weightage alpha, and it is H1, alpha 1 H1 plus alpha 2 H2 plus alpha 3 H3. So now you can see that the output of the AdaBoost will look like this. So you can see that there are no misclassified points. So again I will discuss that. So first of all, there is a data set having two classes, plus and minuses. So objective here is to classify or to separate those points using vertical or horizontal half planes. So in first round it will train a model 1 using decision tree 1 or of depth size 1 on D1, and it will got a hyperplane H1, which is H1 here, and then it will calculate alpha 1 into H1. So how alpha 1 will be created? Alpha 1 will be calculated from this epsilon. So how epsilon is calculated? Epsilon is calculated by weighted classification error. How much classification error is coming from model 1, and then it will calculate alpha 1. So alpha 1 H1 it will calculate from the first round, and then depending on this epsilon 1 it will calculate alpha 1. Suppose alpha 1 is 0.42, so 0.42 into this, 0.42 into this, 0.42 into this. So increase the weights of these misclassified points, which is called upsampling. After upsampling, whichever data set you will get, it is called D2. So in next iteration you will again take another decision tree, which is decision tree 2, let's call it, on D2, and then you will get this type of hyperplane H2 here. So now you can see that these 2 points are which are previously misclassified by this H1, now these points are correctly classified because the weightage are given to those. But now here the problem is to correctly classify those points, it misclassified these minus points. So now it will calculate the epsilon 2. So epsilon 2 is the weighted classification error, and it will see that this type of points are misclassified. So it will give some weightage to these minus points. So now the data set in the third iteration will be D3, and it will look like this.
दरवाजा बंद करा लाव तिला.
So you can see that
तिला दरवाजा बंद करा लाव.
from D3 that these types of these points are misclassified, so it has upsampled these points. So now this is D3, and at last just you train a last decision tree 3 model to that D3. So you will get this type of structure, which is H3 here. So here you will calculate alpha 2 into H2, and now you will see that these 3 points are misclassified, but these points are already correctly classified by those first and second model. That is why it has not upsampled it further. So now you will just combine that. So final classifier will do it will combine or ensemble model 1, model 2 and model 3, which is alpha 1 H1 plus alpha 2 H2 plus alpha 3 H3. So final classifier is called AdaBoost. So AdaBoost is model 1 decision tree 1, model 2 decision tree true, and model 3 decision tree 3. So you can see that this 0.42 is alpha 1, and this is H1, alpha 2 H2, alpha 3 H3. So now the output of the final classifier is look like this, and it is correctly. Yes.
Sir, this alpha is assigned to what? I mean, I can see that the plus sign is, I mean, the size of the sign is increasing, but exactly how is that?
You just give some weightage to it. It means some weightage to it. It means suppose some weightage means how can I say it? So some weightage.
Yes, sir. I'm asking what to what is that alpha assigned to? Maybe if you explain in the first one, it will be clear to me in the first model.
Yes, in this.
Yes, sir.
So alpha 1 is weights given to the misclassified points. So misclassified points are plus these 3 points. So it will you just give this give some weights. Weight means some number. Suppose there is a point of size, I just let's say 5 gram. So give some more weightage mean you will give now you will take as it is 10 gram or 15 gram, so that in next model or next classifier it will take these points as
Okay.
importantly. Have you understood it?
I was considering that those points are multiplied by 0.42. Now it is added, right? Instead
Yes,
of
yes,
1, it will become 1.42.
yes, 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 yes,
Okay,
yes,
okay, sir.
yes, yes,
Okay.
yes, absolutely. So now why it is called adaptive boost or AdaBoost? So in conclusion, you can see that adaptively it just increases the weights of the previously misclassified points. So adaptively it is increases the weights of the previously misclassified points. That is why it is called adaptive boost or AdaBoost. And in sklearn it is already implemented and it is straightforward. Code is no not hard. So there is a module called sklearn.ensemble.adaboost classifier, and there are several parameters, and some parameters are base estimator and n estimators and learning rate. So base estimator means what type of model you want to use. So if you give just none, so automatically it will take decision tree of depth 1. And n estimators mean how many numbers of decision tree you do you want. So in this example we have taken three decision trees. That is why model 1, model 2, model 3. So you can take several number of estimators. So by default it is 50. And then the learning rate is also important. So learning rate shrinks the contribution of each classifier by learning rate. So which classifier do you want to have more impact in your model, so you can use it by learning rate. So and for example, suppose you are given two types of fruits, let's say apples and oranges. And for that you are just given size of these fruits and the weights in grams of this fruit. So now you have to separate that using AdaBoost. So here the features are size in centimeter and weights in grams. So mm, you just first import this import pandas as pd data equal to pd dot read underscore csv. So the dataset name is apples and oranges csv. So if you just type data dot shape, so 40 into 3, it means 40 rows 3 columns. So head you can see that weight, size and class. So now you just split it into train and test, and from train you just create x train and y train. So I look 0 colon 2, it means 0 to 1. So 0 to 1 will be x train and y train this class. So 2 0 1 2. So you just if you print it, you will see that this is the weight, I think, weight and size, and then this is the class. And similarly for test set, you just take this test set and create two folder, x test and y test similarly. And then you just call this AdaBoost equal to AdaBoost you first from sklearn.ensemble import AdaBoost classifier, and then AdaBoost equal to AdaBoost classifier n estimators equal to 100. Then base classifier none. Base estimator means none means decision tree of depth maximum depth 1. And n estimators means numbers of decision tree learning rate 1. And just AdaBoost dot fit x train y train, and you will see that something. So algorithm equal to sam dot r. So in sklearn this AdaBoost class name is sam or sam dot r. So sam dot r is more fast than sam. So by default I think this is sam dot r. That is why it is called algorithm dot sam dot r, and base estimator none. So those are the parameters. And then you just predict y underscore pred on x test. So which I have created x test, and you will see that y prediction is look like this. So whether this prediction is correct or not, for that you have just call this confusion matrix. So you will see that this type of confusion matrix, so there are no misclassified points. So if you create the accuracy, so it will giving 100%. This is a small data set, but in real world, AdaBoost is mainly used in image processing or computer vision tasks. For example, pedestrian or object detection or face detection. So that's it, I think. So if you have any question now, you can ask.
Sir, I have a question regarding confusion matrix.
Yes.
Uh, Sir, confusion matrix is usually used for the Y test and Y pred only, or is it used anywhere else? I
So
wanted to.
so
I
actually
want.
actually for classification type of in classification you can use it. So in regression you can't be able to use it. So one more thing, AdaBoost is it can be used for both for classification and for regression. So here the problem is classification, that is why I have used this confusion matrix. And if you don't have this, then you just call this accuracy which is inbuilt in scikit-learn, then you can also predict it.
No, sir. Okay, that I understood. I am asking that what is, I mean, does confusion matrix have any other role other than uh, just seeing if the prediction and the test thing is
So,
similar or not?
so actually, confusion matrix is saying that how many numbers of points are correctly classified and how many numbers of points are misclassified. So using confusion matrix, you can easily visualize it. But if you want to calculate the recall, precision, or other metric, you will also call this from sklearn, but you can also calculate it manually from this confusion matrix. So this is the significance of confusion matrix. Um, and if you use into your code, then I think confusion matrix is just for to see number of points which are correctly classified or number of points which are misclassified, and no other
Okay,
use,
sir.
I think.
Okay, I want
Okay.
to add one more point, Arun. You are Arun, right?
Yes, sir.
Okay, one more point. So to Shubhankar. So in a typical evaluation setup like precision, recall, this is kind of gross evaluation metric. I mean, it can tell you like to what extent your model is performing and so on and so forth. It's like overall idea. But confusion matrix actually gives a detailed performance. For example, how many samples of a particular class has been misclassified in which classes. Okay, so it basically gives the detailed description or detailed distribution of all the misclassifications. Okay, so you get more detailed view, which you don't otherwise get in typical like evaluation metric like precision and recall and so on. Right.
Okay, sir. Okay, okay,
So
understood.
you take one particular row. If you take the whole row, then what you will see, the row number is 2. Then if you look at the row, then you know that in row number, in class 2, which of the samples are the number of samples in every basically in that particular class, how they have been misclassified to different other classes. Okay, so you get to know these actual numbers. Okay, which you otherwise do not get in other evaluation metrics.